Now, let's move on to question 3 of the November 2022 paper. Now, it says, it is given that the general term of a quadratic number pattern is Tn equal to n squared plus Bn plus 9. Tn is equal to n squared plus Bn plus 9. And the first term of the first difference is equal to 7. Remember that for a quadratic number pattern, the second difference must be common, and the equation is given by an squared plus bn plus c. So we know our general formula for our pattern, so we don't need to find the actual terms of the pattern. And we also know that the first term of the first difference is 7. Remember that the first difference of a quadratic sequence is arithmetic, and we know that the first term of the first difference is equal to 7. Now, I'm just calling it D here. I'm not saying that it is the common difference. Now, let's go to 3.1. Now, in 3.1, it says that show that B is equal to 4. Now, is B equal to 4? How do we find B? Now, the thing about quadratic sequences is that if you have a term A, term B, term C, and term D, you have your terms and you have the difference here. You have the difference. The first term is given by A plus B plus C. And the first term of the first difference is given by 3A plus B. And then the first term of the second difference is given by 2A. If we know the value of the first term of the first difference, that means we know 3A plus B, and that is equal to 7. Now, do we know A? Yes, we do know A, because the general term of the quadratic sequence is given here, and it's usually in n squared plus bn plus c. So this coefficient 1 here represents A. So we know that A is equal to 1. So what we do is that we substitute that A into the 3 plus B is equal to 7, which is the first term of the first difference. And then we solve for B, which is 7 minus 3. B is equal to 4. So we have proved that B is in fact equal to 4. Now for 3.2, it says determine the value of the 60th term in this number pattern. So we are looking for T60. 60th term, it means that for nth term, which is given by Tn equal to n squared plus bn plus 9, we are looking for the 60th term, which will then be T60. Now, T60 means that wherever we see n, we are going to substitute it by 60. Now, what is T60? T60 will be 60 squared. We substitute 60 for n, plus, we know B now. B is 4. So we have 4 into n, and our n is 60 plus 9, and that will give us 3,849. So the 60th term is 3849. Question 3.3 says that determine the general term for the sequence of the first difference of the quadratic number pattern. Write your answer in the form of this form, and this form is for a straight line. Remember that the first difference of a quadratic sequence is an arithmetic sequence. The general term for an arithmetic sequence is given by A plus n minus 1 D. So we need to find 3 things. The first thing that we need to find is to find A, which is the first term, and we need to find D, which is the common difference. Now, the common difference of the first difference of a quadratic sequence is the second difference for that quadratic sequence. Now remember that we said that second difference is given by 2a, and that a is the one that we find in our general formula, and we said that it is equal to a. Now what is our common difference? Our common difference is given by 2a, simply because we know that 2a is the first term of the second difference, and that second difference of a quadratic is the difference of a arithmetic sequence, which is the first difference of a quadratic. I don't want to get lost in what I'm saying here. Now d will be 2 equal to, we know the value of a, which is equal to 1. So our common difference is equal to 2. Now, do we know a? Yes, we do. Now, this might confuse you. Here, when you say a, we are looking for the first term of the arithmetic sequence, which is the first term of the first difference of the quadratic. So maybe let's change it and call it k, and say that k is the first term. Now we know the first term of that sequence is 7 of the arithmetic sequence. It is the first term of the first difference. So our k will be equal to 7. Now that means that our Tn, our general formula, is given by k, which is the first term, that is 7, plus n minus 1, which is multiplied by d, and d is the common difference, and we found that it is equal to 2. Now we just let's call it TP. So we are looking for TP plus 7 plus into, now for n, now we substitute p minus 1 into 2. If we simplify, it will be 7 plus 2 will multiply p and then multiply 1. So we'll have 2p minus 2. Therefore, we have 2p minus plus 5. Now, if you look at this, we have now represented it in TP equal to MP plus Q. This will be our M and this will be our Q. And that is exactly what they wanted us to find. The last question says, which two consecutive terms in the quadratic number pattern have a first difference of 157? Now, in your quadratic sequence, which is now given by Tn is equal to n squared plus 4n plus 9, which two consecutive terms have a first difference of 157? Now that is 3.4. Now that should be simple. We know that this formula gives us the first difference. So it is the general formula for the terms of the first difference. So what we'll just have to do is find the term that is equal to 157. Now we say that 157 is equal to 2p plus 5. So we work out our equation here to solve for p. Now that will be 157 minus 5 equal to 2p. And we'll find that our p is equal to 76. Now notice that between term 1 and term 2, we have difference number 1. Between term 2 and term 3, we have difference number 2. So between T2 and T3, we have difference 2, which aligns with T2. For between T3 and T4, here and here, we'll have difference number 3. So it always aligns with the term before. So if 157 is term number 76 in the first difference, that means it is between T76 and T77.